Today's topic is about various types of industrial fans and their airflow direction. Let's understand air movement and thermal comfort. Human thermal comfort is strongly influenced by air velocity around the body. When the surrounding air is stagnant, a thin layer of warm air forms around the human skin. This layer is called the thermal boundary layer. Since the human body continuously releases heat through convection, radiation, evaporation of sweat, this trapped layer reduces heat dissipation. Air drafting through fans breaks this boundary layer, allowing heat to move away from the body. Two mechanisms then improve comfort. Convective heat transfer increases. Sweat evaporation accelerates. Even a small air velocity of 0.5 to 1 meters per second can reduce the perceived temperature by 2 to 4 degrees Celsius, which is why air movement is critical in industrial spaces. Let's study various types of fans and their air drafting mechanisms. BLDC ceiling fans. Energy saving. BLDC ceiling fans primarily create a vertical downward air draft. Air is pushed from the ceiling toward the worker zone and then spreads radially across the floor. Impact on the human body breaks the thermal boundary layer around the body, enhances sweat evaporation, provides localized cooling sensation. However, their air coverage area is limited, especially in factories with very high ceilings. HVLS fans. HVLS fans generate a large column of slow-moving air downward from the ceiling. After reaching the floor, the air spreads horizontally across a large area before recirculating back upward. This creates a macro-scale air circulation pattern across the entire shop floor. Impact on workers. Uniform air velocity across a wide area reduced heat stratification between roof and worker level. Gentle airflow that improves comfort without creating strong drafts. BLDC heavy-duty exhaust fans. BLDC heavy-duty exhaust fans create negative pressure airflow, pulling indoor air outward. This removes hot air, fumes, contaminated air, impact on workers, improves air quality, reduces accumulation of heat and pollutants, but their effectiveness depends on fresh air entry into the building. Ventilation exhaust fans. Metallic ventilation exhaust systems are designed to create controlled air exchange by moving larger volumes of air. This establishes cross-ventilation across the shop floor. Impact on workers. Continuous removal of heat generated by machines. Lower indoor temperature buildup, improved oxygen levels and air freshness. These fans also come in FRP or fiberglass reinforced plastic body for applications of chemical resistance, corrosion protection, and corrosive exhaust gas exhaustion. Tube axial fans. Tube axial fans are designed for high volume airflow through ducts or confined pathways. Unlike wall-mounted exhaust fans, they are installed inline within ducts, ensuring controlled and directed airflow. They do not spread air in open space. Instead, they transport air efficiently from one point to another. Impact on human comfort. Ensures fresh air reaches deep interior zones where natural airflow cannot reach. Helps maintain oxygen levels and air quality. Indirectly supports thermal comfort by enabling proper ventilation flow paths. Roof extractors. Roof extractors utilize the principle of thermal buoyancy for upward heat removal. Hot air naturally rises toward the roof and is extracted vertically through the roof. Impact on workers. Reduces heat accumulation at roof level. Prevents downward radiation of heat onto the shop floor. Stabilizes indoor temperature gradients. BLDC wall air circulators. Wall-mounted BLDC air circulators produce high-speed horizontal airflow across the shop floor. Impact on workers. Rapid disruption of stagnant air pockets. Strong convective cooling effect on the body. Effective in dense machine layouts. Wall HVLS fans. Wall HVLS fans move large volumes of air horizontally over long distances for deep penetration into workspace. Impact on workers. Uniform air movement across large production lines, reduced localized heat buildup, improved thermal comfort without strong turbulence. Mobile fans. Mobile fans provide directional airflow wherever required with targeted air movement. Airflow direction can be adjusted based on need. Impact on workers. Immediate cooling relief in localized hotspots. Temporary airflow support during maintenance or peak heat conditions. Hanging fans. Hanging fans are suspended below the roof structure for lower level air circulation. This allows them to generate airflow closer to worker height. Impact on workers. Improved air velocity directly in the working zone. More effective cooling in factories with very high ceilings. Closing insight. Industrial fans are not simply devices that move air. Each type controls the direction of airflow differently. Downward circulation, horizontal airthrow, upward heat extraction, cross ventilation. When these airflow patterns are engineered correctly, they significantly improve human thermal comfort, productivity, and working conditions on the shop floor. If this perspective helps you think differently about your factory, then hit the like button, subscribe to the channel, and share with your team. 5-star technologies, creating productive and efficient shop floors.